Welcome to this presentation on using my SuDS estimator. This Excel spreadsheet model has been built to provide a rough rule of thumb estimate of the area of the development site which should be allocated for SuDS. It should only be used at the design conceptual stage, and more detailed hydrological and hydraulic assessments made at later stages in the design process. On the screen you can see the Excel spreadsheet model, and if I zoom in you'll be able to see exactly how I go about inputting the data. The first input field is for a job reference so that you can easily identify which project the model is for. You can enter any relevant piece of information in this field, but for the purposes of this demonstration I'm going to use P01-demo. The title field is to allow a short title or a description to be entered for the project. For the purposes of this demonstration I'll use Demo for SuDS Estimator. The date field is self-explanatory, so you can either enter a date that is relevant to the project you're dealing with, or, as I'm going to do, today's date. The model at present only covers the north of Scotland mainland, but I'm hoping that in the future I'll be able to add additional areas to the model. What you need to do for the location is, once you know exactly where the site development is taking place, is locate the nearest town to it, and then all you have to do is select the town from the drop down list. For this demonstration I'm going to use Dornoch. The model is based on the Wallingford modified rational method, which includes two regions. These are Scotland and Northern Ireland, and the second region is England and Wales. But since this model only covers the north of Scotland, there is only one option available in this drop down list, and that's Scotland and Northern Ireland. The site type drop down list allows you to select either greenfield for undeveloped or rural areas, or brownfield for land previously used for industrial or commercial purposes. For this model I'm going to use greenfield. The two pieces of information in the next section are the total area of the development site and how much of the site will be impermeable after the development is complete. The impermeable areas are those areas that will be covered by buildings, roads, footpaths, driveways and parking areas, etc. You can also enter the total area of the site and the impermeable area in either acres, square hectometers, square kilometers or square meters, but I'm going to use hectares. Once you know the site area, it's simply a case of adding it into the box. If you've worked out the impermeable areas, then you simply add that in the box below. But sometimes if it's an early development stage, you may not know exactly what the impermeable areas are going to be, or how many buildings are going to be on the site, or where the road is going to be located. So in that case it's better to use an approximation, and I normally assume about 45% of the total site area. So we can enter this just using an Excel equation. And this now gives us 45% of the total area as the impermeable area. And that's really all the input data that needs to go into the model. Now as soon as you put in the location up here, it immediately gives you the characteristics of that particular site area, and these are entered in this rectangle down here. The next thing is the model works out the sizing depending on the flows and the volumes that are generated for that particular site. And these are the pre-development and post-development flow rates, flow and volume created during a 1 in 10 year return period storm, the flow and the volume created during a 1 in 30 year storm, and the treatment volume that needs to be considered. This then leads on to this final section, which shows different types of SuDS devices and how much of your development site would need to be allocated for these individual devices. If you wanted to treat the surface water runoff using a filter drain on the site, then with the information that we've put in, you would need to allocate about 220 square meters for that site. If you wanted to provide treatment and attenuation, that would increase to 1,519. The same applies down here for the SuDS swale. 880 if it's just the SuDS swale being used for treatment. If it's used for attenuation as well, then you'd need a much bigger area. The last two are slightly different. These are a SuDS pond and a SuDS detention basin. And the first two figures on this side of the design are the actual size that you'd have to leave for a pond or a detention basin. And the two figures on the right hand side, what I've done is I've added a percentage on to allow for a maintenance strip around either the SuDS pond or the detention basin. And that's really all there is to the model. The model itself is free to download from my website www.idmfraser.co.uk, and at the moment the model is in an early beta stage of development, so any feedback or comments will always be appreciated. Thank you for watching this demonstration, and I hope that if you have any problems you will get in touch.